Hello everyone, let's briefly talk about what we learned in the previous video. A class has properties and methods. These properties are simply a global variable. We can access them through a class. And we can also define local variables in methods, and these local variables will exist in methods and they are not accessible from anywhere. And when we say dog1 is equal to new dog, that means we have instance variable, or we can call them object or reference variable, or simply we can call them pointers that are pointing the object in the memory. Let's see what's happening in the memory when we create an object. Let's say we have a dog, and then in the dog we have breed, age, and color, and we have bark method here. If I say dog1, dog2, reference, I created an instance for them, and that means we are creating instance variable in RAM, and in the RAM we have two sections. Let's say we have two memory types, stack memory and heap memory. This stack memory is for static memory allocation, and we store variables, and then we store this reference variable here. On the other hand, in the heap memory, we use it for dynamic memory allocation. That means when we create an object, we put them all here, and these reference variables are pointing or referencing this object in the memory. Let's say if I say dog d1 is equal to new dog, it's going to create a reference variable called d1, and that reference variable is going to create a new dog in the heap, and then we will set the value of each variable for this dog. Since we haven't assigned the value for breed, age, and color, it's going to take their default values. Default value for a string is going to be null, for age it's 0, and for color it's going to be null again. Similarly, d2 is going to be the same, but different objects. And then if I say dog d3 is equal to d2, it's not going to create a new object. Instead, it's going to create a reference variable that pointing the existing object, which is d2. So if I do anything, any change for d2, it will be reflected back to d3 because they are same objects. And here is a good example. We have dog 1, 2, 3, and 4 in the stack memory, and in the heap memory we have objects for them. For example, d1, d2, we created object here. If I say dog2.age is 10, since dog2 and dog3 they are pointing same object, that means if I make any change here for dog2, dog3 will get the same value because they are same objects. And look at here, dog4, we haven't initialized it yet, we haven't set it to any object. That means it's null value, it is undefined, therefore it has no value in the heap memory. You can simply call them, it's a null object or null pointer. Now let's talk about primitive types and reference types. We are dividing types into two main categories, primitive and reference types. Primitives are Boolean, byte, character, short, integer, long, float, and double. And they can store exactly one value of its declared type. You cannot take different types, just one value. Other types called reference type are classes simply. They specify the types of objects and we call them reference type. Primitive types instance variable are initialized by default. For byte, character, short, integer, long, float, and double, they are initialized to 0. For the Boolean, false. On the other hand, reference type variables store the location of an object in the memory, and we can call them object in a program. That object may contain many instance variable and methods, as we can see here. It is d1, but d1 is containing breed, age, and color, different variables. And reference type instance variable by default, the value is null, but if we create a new object, it's going to point the object in the heap memory. And then using a reference, we can call object methods, but for primitive types, Since they are not objects, we cannot call methods. So I would like to show an example. And in this example, we'll talk about access modifiers here. So in object-oriented programming, we said that the main focus is data hiding. So we need to control the access of data. For this one, we have access modifiers. In C#, we have a couple of modifiers to set the access level for a class, variable, methods, or constructors. We have more than 4, and for now, we will talk about 2 of them, public and private. If you put public modifier in front of the method or variable, that means the code is accessible for all classes. If you put private, the code is only accessible within the same class. So let's talk about them. I would like to create a new class called, let's simply delete them all and add class called student. And then for this student, I want to have string name, float value, midterm exam, float final exam. And then I would like to have a method called float compute average. Let's say we would like to have, compute the average, getting midterms 0.6, which is float value, and then final 0.6. And then we will have this value, it's going to be average of students here. And if I create new class, I want to call this add class and then call this main class. And in this main class, I would like to have public static void main method and then string. This is just by default method in C#. I would like to say student is equal to new student. But if I go here, you can see that I cannot access to this student's data. I cannot say name is, for example, Jack. And then maybe midterm is going to be 50 and final is going to be 100. What is impossible? Because we have no access modifier, and if I have no access modifier, that means it's by default. C# doesn't allow you to access them. If you want to access them, you can simply put public in front of them. That means any class in the project can access this value. Now you see it's working here. Let's say I want to create another method called private. I can say average, float average. And then I would like to say average is equal to this one and return average. This time, sorry, if I make it public, this is dangerous because average value is produced by class because it's considered midterm exam and final exam and compute the average value, and I want to return this average value. That means if I make this public, it's dangerous. For example, for this student, I can say console write line student and then get average. Sorry, compute average. There must be, okay, I cannot access compute average. The reason is because it has to be public. So I can't access it right now. Compute average. Here, good. But let's say if I say student and I want to say maybe average is 67 and write the same thing, student, then compute average. That means actually I have to just console read, otherwise it won't be able to see read line. See the content in console window here. Maybe it's better to write this one here. So see what's happening. Normally the average is 80, but I change it to 67. This is violating data security. That's why this age, the average value, should be private. It cannot be public. So make it private. So no one can access it directly and no one can change it. So it won't allow you. Student average is inaccessible due to the protection level. So if I want to access the average, I can simply access the average through this public method here. For this kind of things, we have to use private because this data is processed within the class and it shouldn't be there. If you want to show it, display of the only average value, you can. For example, if I want to make something private, I can say private, maybe student ID, integer student ID, and then if I want to change this value, I can use set, but we'll talk about them later. No need for now. The idea is clear. If something is public, it's accessible. If it's private, not accessible. Later on, we'll talk about protected and internal, but this is after inheritance. It's better to talk about them. Now let's talk about constructors. A constructor is a method to initialize an object. When you create an object, if you want to set some value, then it's better to use constructors. Let's say for this student, this is one way, by the way. In C#, there's another way. We can have constructor. For instance, I can say public. The name should be same as the class. And if I want to set this value, I can say string, name, float, midterm, and then float, final. Then I can say, when you create an object, request this parameter from the programmer, and then use this one, set the name to this one. I can say this name is equal to name. So it will take this parameter and assign this to the global name. And then this midterm is equal to midterm. This final is equal to final. So now if I do this, there will be a problem here. It will say that this is actually a constructor. It will say a constructor requires some parameters. It requires name, check. It requires midterm, for example, integer value 80 or final 90 here. Now we don't need to use this curly bracket to assign them. So it's automatically here. Let's say when I want to create an object, if I don't want to set name, I can use another constructor. Maybe this time I don't request anything. I don't have to set the name. I want to only set midterm and final for student. So we have this kind of constructor. If you have one constructor with different parameters, that means you are overloading the constructor here. But here in object-oriented programming, we shouldn't repeat the same code. Since we have the same assignment here, instead of assigning this like this, we can directly call this constructor. To do this, we should do this one, this midterm and final. So we have to call alternative constructor from here. Just cut it here and then put column and then here. That means you are, first of all, to assign the midterm, you are calling this constructor and you're getting this midterm value to set to midterm, and then you're taking this final and you're setting the final. I would like to show you what's happening here. Simply put breakpoint here, another breakpoint here. Run it here. Take a look at here. Now we have an object, So we are creating constructor. Which constructor? The constructor with 3 parameters. So that one, name, mid, and final. And that constructor, it's calling another constructor because we want to set midterm and final. We can write them here, but we don't want to repeat ourselves because there was a dry rule. Don't repeat yourself in object-oriented programming. Therefore, we can call another constructor using this one. Just continue. Take a look at here. We get the mid and final value, and we set the mid 0. Now it's become 80, and then for final it becomes 90. So we set them, and after that we set the name. It was Jack, and then we set name to Jack, and then it's done. We set name Jack, midterm 80, final 90. We haven't compute average value, therefore it's 0. And when we call this compute average method for this object, it will automatically, once you put another breakpoint here, automatically compute it for. You see, now we have average, and average value is 86. So it's 86 here. And I'm done. We can call as many as constructor we want. We can create as many constructors we want. It depends on our needs. If you don't have any constructor, C# is going to create a default constructor in which you can set your value if they're public. For example, if this midterm is a private, that means you can still assign the value here because that means you're taking parameters and then you assign it. But if I want to say, for example, I want to change student final to maybe 85, this is possible because it's public. But if I want to do the same for midterm, and then I want to make it 90, for example, it's not acceptable because midterm is a private value. No one can change this, no one can access this. Not only for set the data, you cannot also access it. Student, then midterm. So no access at all, no setting, no getting here.